Okay, this is connecting f prime, and f double prime, but we're going to look at the graph of f prime, and I'll ask you some analysis questions about this graph of f prime. This is actually an old FRQ question. This is a classic AP exam type question. So part A says find all critical numbers of f and classify them as mins or maxes or neither. Remember, you're looking at the picture right now of f prime, not f, but this is the graph of f prime. So we have a critical number when f prime of x equals 0 or is undefined. It looks like f prime is always defined, so I'm not really worried about that, but where does f prime equal 0? So that happens at x equals -2. It happens at x equals 1 as well. We will not count x equals 4 because while it is a critical number, you're equaling 0, you won't be able to figure out if it's a relative min or a max necessarily. Okay, so we will always exclude those endpoints. And plus it tells me that we're differentiable only on the open interval, so we really don't know what's happening on 4 at the end there, okay? So x equals -2, if you notice, the graph, the derivative, this is the derivative, goes from positive to negative, which means that x equals -2 is a relative max because f prime changes from positive to negative, is our first critical number. And x equals 1. Now notice how it stays negative on either side of the critical number. F prime stays negative. So that means x equals 1 is neither a relative min or max because f prime does not change sign. Since we have no sign change, yeah, we can't really say that that is going to be a relative min or max. Okay, so that's first part, part A. Part B says on what open intervals in -3 to 4 is the graph both concave down and decreasing? So let's just remind ourselves how to identify when the graph is concave down. This is when f double prime of x is less than 0 or when f prime decreases. That's really important because we're looking at the f prime graph. And when is the function decreasing? So when does f decrease? F decreases when f prime of x is less than 0. So let's start with that first, okay? When does f decrease? And I'm going to highlight those parts in green, okay? So when does f decrease? When f prime is less than 0. F prime is less than 0 all here, okay? This is all the parts where f prime is less than 0, of course excluding 1 and -2. So that's when f is decreasing. Now, when is f concave down? I'm going to highlight that in purple. Okay, so when is f concave down? That will happen when f prime decreases. So f prime decreases, like right here is where f prime decreases, and it goes down to right about there. Oh, I hate when that straightens out like that. F prime decreases like right to here, okay? And then it also decreases like right here as well. So these are the places where f is going to be concave down. When f prime decreases, the slopes are getting smaller. Slopes are getting smaller, of course. So where does that overlap happen? That happens on the open intervals -2 to -1, union 1 to 3, because f prime of x is less than 0 and f prime of x is decreasing. Remember that I just said this, but remember that when f prime of x is less than 0, that's when the original f is decreasing. But when f prime of x decreases, this right here, just so you know, this is where I get my concave down interval. This is where I get my increasing interval, but I get my concave down when f prime is decreasing. And then finally, part C says this: find all the x coordinates of all the points of inflection for the graph of f and justify. Okay, so if you want a POI from the f prime graph, you need to see when does f prime change from increasing to decreasing or vice versa. Will give you a point of inflection. When does the f prime graph change from increasing to decreasing or vice versa? Okay, so I'm going to look at my picture. When does the graph change from increase to decrease or vice versa? That's going to happen like, I'm going to do this in green. I'll do this in blue. Okay, that's like right about here is where f prime changes from decrease to increase. It changes from increase to decrease here, and then from decrease to increase here. So I actually say there are 3 points of inflection, because this is where the second derivative, f double prime of x, this is where the second derivative, f double prime of x, equals 0 here, and here, and here. So that happens at what? -1, 1, and 3. So x equals -1, x equals 1, and x equals 3, because f prime of x changes from increase to decrease or vice versa. And that's also where f double prime of x equals 0 and changes sign. You could also use that as a justification as well, and changes sign.